Hello everybody, my name is Matthew Godat and welcome to my Lab 5 video. The purpose of this lab is going to be to predict and analyze the motion of a slinky using GlowScript code and the tracker software. And we're going to see that when a slinky is dropped, the bottom of the slinky will remain stationary until the slinky is no longer stretched. The key ideas that we're going to be using are going to be Newton's second law, which is velocity final is equal to velocity initial plus F net over m times delta t. And then we're going to have the gravitational force of negative mg, the drag force of v squared times v hat, and then the tension force, which is going to oppose that of gravity inside the slinky. Moving on to the experiment, using a video found online, the motion of a falling slinky was analyzed in the tracker software, and this allowed us to obtain position versus time data. And from these two screenshots, you can see in this first one at a lower time, the bottom of the slinky is at this point, and then later when the slinky has fallen, the bottom of the slinky is still at this point. Moving on to the code, we first have to give our code its initial conditions, and these are obtained from the video. We have our mass, position, velocity, and drag constant. You can see that we have mass, position, velocity, and the drag constant. Moving to the while loops inside the code, we actually are going to have two while loops in this. One exists for the time in which the bottom of the slinky is stationary, and then one for when the bottom of the slinky is moving. This is because we have different forces during these two time periods. So loop 1, we have the equal and opposite force to gravity and the tension force inside the slinky. You can see that here. And then loop 2, we have a net force that is not equal to 0, and we're going to see some motion. Here's an output of that code. You can see the slinky falling here. This is our mass. But we get this graph where we have a constant position up until this point, and then we start having constant motion. Moving into the results of this experiment, combining the data from the experimental and GlowScript model, we get the same pattern, which is it's flat at first, and then moves into a slope after a certain amount of time. And we're going to have the possible error here of missing just accidental points inside the tracker software. So why does the bottom of the slinky remain stationary? And this is because the gravitational force on the slinky is canceled out by a tension force of equal and opposite magnitude inside of the slinky. Thank you for listening, and I hope you enjoyed.